Evaluate the expression and answer in polar form. Oh, dividing by a complex number. The way to deal with that is a little trick. What you want to do here is you want to multiply by its conjugate. Okay, what does that mean? It means the opposite in the complex or in the imaginary side. Okay, if I multiply this, I'm going to get a perfect square, and I am going to remove the I component, remove the complex value of it. So let's do that. So let's multiply by 2 minus I, so we're multiplying by 1, right? This whole bracket here is 1, so that's no problem. You can multiply by 1, and I'm going to show you why we're going to multiply by 2 minus I here, because we're going to remove the complex part. So we have to do a double FOIL. That's awesome. And here we go. Let's start with the bottom. So 2 times 2 is 4. 2 times negative I is negative 2I. I times 2 is plus 2I. And then I times I is negative I squared. Negative I squared is equal to negative, bracket open, I squared is equal to negative 1, so it's equal to plus 1, plus 1. Okay? Okay, top, we got 3 times 2 is 6. 3 times this one's going to be negative 3I. This one's going to be negative 2I. And then we got negative, or it's positive I squared, which is negative 1. Okay, let's simplify this guy down here. So we're going to get 6 minus 1 is going to be 5. And minus 3 minus 2 is going to be minus 5I. And on the bottom here, here's why we did it, okay? Because we get negative 2I plus 2I, bye-bye imaginary part, and all we're left with are real components. So we got it divided by 5. Look at that. And it even divides by 5. It can even divide both out. But really, if I didn't want to, if this didn't work out, I could always write it as, like, 5 over 5, or whatever the value it is, minus 5 over 5I. Okay, and now we're back into not dividing by a complex number. We're just regular complex numbers, and we're good to go. Now, this one works out beautifully because it goes down to 1 minus I, which is nice. And we're done. Oh, polar form. Okay, well, now we have to convert it to polar form. So let's convert this into polar form. It's going to be 45 degrees, right? 1, 1 for sure. Radius, what is that? Real and imaginary. And we got plus 1 here, and then we got minus 1 here. So here's our vector. And this guy right here, I guarantee that's going to be pi over 4. Minus, but we'll solve for it anyways. So we're going to solve for theta and r. So theta is going to be equal to tan inverse of opposite, which is going to be 1 over 1. And that will give me a value. And then radius is also the square root of 1 squared plus negative 1 squared. And we are going to be equal to tan inverse of 1 is that number. Oh, is it going to be pi over 4? How am I going to tell? How am I going to put that into pi over 4? Well, I'm just going to make it equal to some value times pi. Can I use x? Did I use x? No, I didn't use x. So I can make it some value times pi. So now I can just solve this equation right here by just dividing both sides by pi. So I'm just going to take that and divide it by pi right there. And I'm going to get 0.25. So that means that x is equal to 0.25. So that means that this does work out, and it is equal to 0.25 times pi, which is equal to pi over 4, which is awesome. Now, here we go. Here we're going to have 1 squared plus 1 squared, bracket close, or answer, and we get 1.41, which is also equal to root 2 there. You saw that, right? 1 plus 1, 1 squared plus 1 squared is equal to 2, so root 2, so let's keep it in that. It's a nice form. And our answer will be equal to root 2 e to the negative. Got to remember the negative, because if I put positive, I mean up here, and I don't mean up there, I mean down. So we're going to go negative pi over 4I. Okay? Now, we could have went the other way. We could have went all the way around, because this is equal to, well, it's going to be, what's 1/4? So this is 1/4. It's 1/2. 3/4. 1 pi. 1 1/4. 1 1/2. 1 3/4. Right? It's 1 3/4. Yeah, it's 1 3/4. So I could have also had it as 1 3/4 pi, or 4 is 7. Yeah, 7 over 4 pi. Right? So that's also the answer. That's going around this way here. But this is nicer. And we're done.